Hello everyone. Today we're going to go over some assembly instructions. Basically, we're going to go over how to declare a variable and how to use some data transfer instructions in assembly. So let's get started. So to declare a variable in assembly, what you have to do is the basic syntax is variable name, directive, and the value. Okay, so variable name, that's going to depend, that could be anything. Let's say it's hello. Now the directive is the type of integer that this value is going to hold. So it depends on the type of integer that the variable is holding. So let's see, if you wanted to hold a 16-bit unsigned integer, you would use the word keyword. So over here, you'd say word, and then the value would be something like this, right? So now the variable word, the variable hello, which is a 16-bit unsigned integer, holds the value 1h. Okay, so I've made a chart over here detailing all the some directives. This is not the complete set of directives, but as you can see, byte is for 8-bit, and then word is for 16-bit, D word is for 32, F word for 48. If you're wondering what the difference between signed and unsigned ints are, so a signed int is basically an integer that can hold a positive or a negative value, whereas unsigned int is a value that cannot be lower than 0. So basically an unsigned int cannot hold a negative value. Okay, so that's how you declare a variable, and the value of the variable would determine the directive. So if you have a 32-bit integer, so like that, yeah, so 32-bit integer, you would have to go new int, so you'd have to go D word, right? Why is this? Because 32 integer needs the D word directive. Okay, so now let's go over some data transfer instructions. So the one that's most obvious is the MOV, and basically the syntax for it is as follows. So you have the destination and the source. Basically this instruction moves data from one location to the other. So let's say you had a variable variable 10h, and you wanted 10h to be assigned to hello 2. You can't just do this in assembly. You can't do this in assembly. That's invalid syntax. What you have to do is you have to move this and this into two different registers, and then move one register to the other, like follows. So move, let's use the EBX register and give it the assign it the value. Move the value of 10 hexadecimal, and now we're gonna say we're gonna move EAX. We're gonna move EBX into EAX. EAX, in which case uh, EAX equals 10. And EBX also equals 10. Okay. By the way, the H over here signifies a hexadecimal value. So whenever you have H, you know that this value, it's not in decimal form. So this 10 is not actually a 10. It's the hexadecimal equivalent of 10. Okay? To define a decimal value, just take off the H, and now that's a decimal. So let's go with the MOVZX instruction. It's basically the same thing as MOV, same syntax, but with one little addition, which is, so let's say you have this integer, it's gonna zero extend this integer into the destination. So let's say source EBX. Let's move this into the EBX directory, register. So now EBX has the value 10H. Now, if I move EBX into EAX, assuming this is a 32-bit integer, we'll have this value. Why is this? So we know that a 32-bit integer has 8 digits. So that means the unused bits, which were not displayed here, are displayed here. And they're 0 extended to the most significant bit, which is the ending bit right here. So basically this shows all the missing zeros, right? So that's what MOVZ does. MOVZ does, and so now let's go over MOVSX, which is basically the opposite of MOVZX. So it's gonna have the same syntax, move destination, source, move something from the source to the destination. Except now let's use the same example. And we have EBX directory, register. EBX, and now if we move EBX into EAX, EAX will be sign extended, which means this will be the value of EAX. Why is this? So sign extension is basically the opposite of zero extension. Sign extension fills up all the unused bytes with ones instead of zeros. So that's why I said this is the opposite of MOVZX. Okay? So basically fills it up with zeros while moving the 10. Right? Let's see, the 10 is still there. Okay? So that's basically what I wanted to go through. Oh, by the way, let's go back here. This is how you declare a comment in assembly, by using semicolon as a prefix. So all characters following the semicolon will be ignored by the assembler. Okay, so this is how you declare a comment. And that's about it. Thank you for watching this. See you guys next time. Please like and subscribe. And have a nice day.